Hello everyone. So, now we're going to examine some proofs involving CPCTC. If you don't remember what that means, it means corresponding parts of congruent triangles are congruent. So we're going to start out the process same way as always. Start out with our givens. So we have that AB is congruent to AD, and that's given. We have that BC is congruent to DC, which is also given. And it wants us to find or to prove that the angle BCA is congruent to the angle at DCA. So unlike the last proofs where we wanted to just simply prove the triangles are congruent, now it wants us to prove that these specific angles are congruent. So let's mark what we've been given, that AB and AD are congruent, and BC and DC are congruent. Well, I mean, we have two pairs of sides, right? Two pairs of sides. And I can see, well, that they share the third side, AC. So I'm going to write that AC is congruent with AC because of the reflexive property. And that marks our third pair of congruent sides, which means we have SSS congruence. So I can state that triangle ABC is congruent to triangle ADC by side congruence. So I've established that the two triangles are congruent. And remember, the definition of congruence means they have the same, the corresponding sides are the same, and the corresponding angles are the same. Now let's look at angle BCA. BCA is this one, and DCA is this one. And they certainly correspond with each other. BCA, DCA, it's the second, third, first letter in our statement. So they are certainly corresponding angles, and since we know the triangles are congruent, the corresponding angles are congruent. So my reasoning here is going to be CPCTC. The corresponding parts are congruent. Now if this is a little weird, let's take a look at another one. Okay, we have a given such that PS is parallel to QR, and of course that's a given. And we can probably just fit it on one line, whatever. It doesn't matter. Angle QPS is congruent to angle SRQ. And it wants us to prove that PQ is congruent to RS. So let's look at what we got. Angle QPS. So that's angle QPS right here. Is congruent to angle SRQ. This one right here. And PS is parallel with QR. So again, parallel lines are very important. Let's mark those. PS is parallel with RQ or QR. And our transversal seems to be this QS because it crosses both parallel lines. Now from there, I can easily identify that this angle here is on both the transversal and the parallel line. And so is this angle right here, transversal and parallel line. They're on the interior section, the inside of the parallel lines, alternating sides. So what that tells me is that I have that angle PSQ is congruent to angle RQS. And why? Because they are alternate interior angles. Therefore, I have two pairs of alternate of congruent angles, the one here and the second one here. I also note that both triangles, PSQ and RSQ, or RQS I should say, share that same side QS, the transversal. So I can state that QS is congruent to QS because of the reflexive property. Now, because of this, I have two pairs of congruent angles and a third side that's not included, but we can still see that we have angle to angle to the side. We have angle to the other angle to the side. So I can establish the fact that triangle PSQ is congruent with triangle PSQ would be RQS because of angle side congruence. And therefore, we can even just leave this whole thing out because I'm done. Because by CPCTC, I know that the corresponding sides of PQ and RS must be the same as well. So those are some examples of proofs that involve CPCTC.